Hi everyone, today I'm going to show you this heads-up display module I built for my car using Arduino, 7-segment display. Plug it. A little optocoupler, 3.5mm jack. We got a little chip here, it's a Max 7219. This runs the 7-segment, and of course the 5-volt regulator. So, a few of the design criteria I wanted for this project was it had to be compact, that way you could leave it on your dash. It wouldn't take very much space, it'd be easy to implement. Another one was keep it simple, so I just wanted kilometers. I didn't want to clutter the windshield with unneeded information. And most of all, high refresh rate. That is one thing that has bothered me on commercial heads-up displays, is the low refresh rate. There'd be a second or two before it would update, and that annoyed me a lot. So this project solved that issue, and I've been running it for a couple weeks in my car, and I've been very happy with the results. So now I'll show you guys the wiring diagram. Alright, so this is the circuit. A little disclaimer, I'm still very much an amateur at this electronic stuff, and this circuit could always be improved. Otherwise, we'll take a look at it. So here we have the Arduino. It does the thinking, does the math. The Max 7219, this runs the 7-segment display here. And of course, we have a LM7805 that gives 5 volts power to all this stuff, including the optocoupler. And the optocoupler, of course, which helps clean up the signal coming from the PCM and feeds it into the Arduino. So let's start at the beginning. 3.5mm jack. This is where we get our power from the 12-volt socket in the vehicle. And then we have a wire here. This comes from the PCM. Triggers the LED. Optocoupler has a Schmidt trigger, and it pulls it to D2. The Arduino does the calculations, sends the data to the Max, and then it runs the LEDs. The 330 ohm resistor is to limit the current in the optocoupler LED. The 1K is to pull up, so it returns to positive. And the 9.8K resistor here, that limits the current in the Max 7219. If you want to know more, there is a data sheet regarding this chip. So it's pretty straightforward. So now we'll take a look into the vehicle side of the wiring. So near the bottom of the powertrain control module, we can see here, there's the countershaft speed sensor. This is what the vehicle uses to measure vehicle speed. But because this is the countershaft, it doesn't measure directly at the differential. So the computer does a bit of math for me, which is nice. And all I have to do is at pin A9, take this VSS out and basically splice it into my Arduino, which is what you saw earlier on the diagram. So this particular vehicle will pulse 4 times per tire revolution. So that makes my job easy in the code. I can just specify that and it'll output the correct speed, though I have to put the correct tire size, that way it's not totally off. Alright, so this is the code I use to run my heads-up display. It's from a YouTuber called InterlinkKnight. He made an excellent video on an RPM gauge, and it measures basically instantaneously the RPM given. So it's very useful because RPM can be converted to kilometers an hour if you know the diameter of your tire. So this math here does it for me. And then over here we have some if and else's. That way there won't be 0 digits. Let's say if you're going 0, you won't have 3 0 digits. It'll just be 1. I'll leave the link in the description for this code. That way if you want to run it, you can. So after completing the circuit, I tested on a breadboard in my vehicle and it worked pretty well. So I decided to make it onto a PCB, make it as compact as possible. And here we have a 3D view. So pretty compact. And then I sent it to GLC PCB, and 2 weeks later I got this. So looks pretty good. I populated with the components and tested in my vehicle, and it worked pretty good. Alright, so that's basically it. There are a lot of improvements you can make on this device. For one, instead of having this flimsy little cardboard thing, you'd make a proper enclosure, put some tint, that way the segments aren't visible during daytime. Maybe put some capacitors and some protection in the circuit, but for V1 I think it's pretty good. I thought I'd put it out there, and I'll show you some video of it in action. All right, there's the module install. We'll do 0 to 100 kilometers an hour. Now we're coasting. Pretty responsive. I'm happy with the results.